those of you alien institutors who want to hear more details on the topic of why mathematics can be so difficult to learn, continue watching. To immediately hear Richard Feynman's take on the subject, go to the time frame being pushed across the screen.
Why, for many, is mathematics such a difficult topic to learn? To answer that question, it's important for us to travel in our minds back to our childhood. As a child, we are already doing mathematics naturally before we even step into a classroom. Mathematics compartmentalizes everything. And as children, we compartmentalize mom and dad, dog, cat, big TV, small TV. Kids also know the difference between one and many in the way they use the plural of a noun. A young child points to a chair and says chair. And if there's more than one chair, the child now says chairs, recognizing a multiple of the same item. In the same vein, they also enforce the general rule of adding an S to imply more than one thing. The concept of greater than and less than is also understood. A kid who has never entered a math class can point out that one dish has more cookies than another dish. Of course, a little later, the abstract symbol of numbers enters their forming brains, and quickly they can say things like, "We need 4 chairs because there are 4 people," recognizing there can be a functional connection between one category, people, and another category, chairs. Now, a kid that makes a statement like, "There are 4 people, 8 arms," is really advancing within their daily household laboratory of mathematics. So what happened? Your problem and my problem was that school happened. In many ways, schooling has re-educated our natural mechanisms to switch off. In school, we copy or take notes off the board, we learn to follow strict rules, we're taught to over-memorize things, blindly analyze, and fear making mistakes. There's one thing I know for sure, that strict rules and fear of making mistakes is a sure way to stagnate a fertile mind. Of course, learning an algorithm and memorization will be part of your learning process, but it really needs to be a fraction of the student's mathematical experience. In some schools, it's sad. They tell you to memorize things, and they neglect the most important part. The school neglects to offer you methods and techniques from the latest research that will help you to become great at memorizing. Go to this video right here for a good starter video on memorizing. As for algorithms, a great education would gently guide the student to develop the algorithm on their own. If, as a kid, you developed daddy, mommy, sister, brother for the division algorithm of divide, multiply, subtract, bring down on your own, of course with some good guidance, obtaining it on your own would certainly lock it in your memory, and it would also pave the way in the abilities department to solving bigger unanswered problems. Of course, that's not the way my learning experience went, and I bet your experience wasn't any more illuminating. Most schools must force feed one way of doing mathematics because, 1, the teacher is almost always not a mathematician. 2, the classroom is always in a hurry. There's never time to ponder things. And 3, it's next to impossible to individualize a student's lesson since there are so many students at different levels of their mathematical journey. One way to make students more successful in math would be to have 2 math classes per semester starting at kindergarten. One class period being more of a laboratory with manipulatives, whiteboards, rulers, weight scales, blocks, etc., where the laboratory class would support the second math class that would follow somewhat of a traditional format. Even better, a third hour could be added, a third hour of study hall with experienced tutors to summarize the mathematical material for that day. 3 hours a day on math may sound excessive, but it's really essential in the beginning. Anyway, the quote, perfect mathematical classroom is a discussion for another day. Today, what I'm going to do is share with you a prominent American theoretical physicist and teacher, Richard Feynman, and an experience he had as a kid sitting in and observing his older cousin getting tutored in algebra. To hear him speak on the topic as an adult really zeroes in on how to approach problems, essentially from one's own operational steps. In other words, think and then create a path to the solution, your own personal path. Just think. If you think and create a path to enough solutions, you just might surprise yourself. You just might become a physicist like Richard Feynman.
My cousin at that time, who was 3 years older, was in high school and was having considerable difficulty with his algebra and had a tutor, Chem. And I was allowed to sit in the corner while the tutor would try to teach my cousin algebra. And so problems like 2x plus, I said to my cousin that, I said, what are you trying to do? You know, I hear him talk about x. He said, well, you know, 2x plus 7 is equal to 15, he said, and you're trying to find out what x is. I said, you mean 4? He says, yeah, but you did it with arithmetic. You have to do it by algebra. And that's why my cousin was never able to do algebra, because he didn't understand how he was supposed to do it. There was no way. I learned algebra, fortunately, by not going to school, by knowing the whole idea was to find out what x was, and it didn't make any difference how you did it. There's no such a thing as you don't do it by arithmetic, you do it by algebra. That was a false thing that they had invented in school so that the children who have to study algebra can all pass it. They had invented a set of rules which, if you followed them without thinking, could produce the answer. Subtract 7 from both sides. If you have a multiplier, divide both sides by the multiplier, and so on. A series of steps by which you could get the answer if you didn't understand what you were trying to do.
Before exiting our spacecraft, be sure to strike the like, subscribe, comment, and share